Hello again, this is Math 1115, remote delivery for April 20th, 2020, and this is part 1. This covers in your textbook material from section 6.4, and I encourage you to use controls like this in YouTube to perfect your understanding. In consultation with John, we've made a decision not to cover the sum and difference of cubes. That's a factoring technique. But in my life as a professional mathematician, and many years, I have used this exactly 6 times in my work. My guess is that many of you would never encounter it again in your work, and so we're skipping this term in favor of higher priority material. The fundamental principle of fractions says that the value of a fraction is unchanged if you multiply both the numerator and denominator, or divide both the numerator and denominator by the same non-zero number. And the fractions are said to be equivalent if one can be obtained from the other by use of this fundamental principle. So, for example, 6 over 8, 12 over 16, are both equivalent to 3 over 4, because here I would divide top and bottom by 2, and here I would multiply top and bottom 6 over 8 by 2, and so and 3 over 4 is what I get is if I were to divide both top and bottom by 4 here. So there are many fractions like this, but those are called equivalent fractions. We can also have equivalent algebra fractions. Here we have 3 over 6. 3 over 6 is 1 over 2. 3 goes into 3 once, 3 goes into 6 twice. A squared over a is going to simplify to just a to the first power, and I have x. So this is an equivalent algebraic expression, and it is simpler. We call the simplest form lowest terms of a fraction. So a fraction is to be reduced in lowest terms. You use the fundamental principle of fractions and divide both the numerator and denominator by all factors that are common to each. Here's an example. 8 goes into 16 twice, 8 goes into 24 3 times. A over a is going to be 1. B cubed over b squared is just going to be b, and c squared over c to the 5th is going to be c cubed in the denominator. So when you cancel those common factors, what you will get is 2b over 3c cubed. Here's a caution that is worth noting. It is very important that you cancel only factors that appear in the numerator and denominator. This means that the numerator and denominator must be in factored form before making any cancellations. It is a common error to cancel expressions without factoring first the numerator and denominator. In particular, terms, expressions separated by plus or minus signs, cannot be canceled. Okay, so here we're going to factor numerator and denominator completely first. Now the denominator factors into x minus 2 times x plus 2. Everything is fully factored, and I'm canceling factors. X minus 2 goes into x minus 2 once, x minus 2 goes into x minus 2 once, and so the resulting simplification is this. Now in this problem, it is okay to cancel the 2 a's because everything is in fact fully factored form, and we're only canceling factors. But over here we have 2a over 2a plus x. In the numerator it is a factor, but in the denominator it is a term. It cannot be factored. This cannot be simplified further. Here again we fully factor the top and the bottom. Here we factor out the common factor of 2x. We get x plus 4. Here we factor in, there is no factoring, it's just x plus 4, so x plus 4 goes into x plus 4 once, x plus 4 goes into x plus 4 once. Note that here the only thing that's left is the 1, but it is important that the 1 be there. 2x over 1 is 2x. Here we factor the numerator and the denominator, and we cancel out the x minus 2 factors, and we get this. We can't cancel any further because x is a term, not a factor. Here is another problem. We factor out the common factors, and then we also factor further. The only common factors that we have are 2 goes into 2 once, 2 goes into 4 twice, but then 2s plus 3 is a common factor to the numerator and denominator. It may be canceled. So in the simplified form, I just have 2 times s plus 5. Again, 2s plus 1, or 2s plus 3 goes into itself one time. Often you will run across situations where we will have in either the numerator and denominator an x plus y, but then we'll have a y minus x, x minus y, and we'll have a y minus x in the numerator. And it's important to realize these are negatives of each other. They differ only by a sign. Here's an example. So let's factor numerator and denominator. You see up here we have a x minus 1, but down here we have a 1 minus x. When we cancel those, we get a minus 1. And this is going to be minus 1 times x plus 1. Here is a more complicated factoring situation. And note that here, this example, they actually are using the difference of perfect cubes. Again, you're not going to be tested on that. But what happens here is they are using that factoring thing. But the important thing for you is to realize that you have a 4 minus x down here, and you have an x minus 4 up here. So when you cancel that, that induces a negative sign in your final answer. So here is a good opportunity for you to perfect your understanding by trying these sample exercises. I'm asking you to pause, see how you do before doing John's recommended homework, and let's see how you do. Let's see how you did. Make sure you know how to do these before you go on. This ends part 1. There will be a part 2, so I will see you in part 2.